this lesson, we will go over basic concepts in hierarchical clustering. We will go over agglomerative clustering and divisive clustering basic concepts. Hierarchical clustering addresses an important limitation in flat clustering methods like k-means, which is the need to predefine k, the number of clusters in advance. Instead of fixing k arbitrarily, hierarchical clustering builds a multi-resolution structure of the data. You can think of it as creating a nested hierarchy where smaller, finer clusters can be merged, or on the other direction, larger clusters can be recursively split into smaller ones. Let's think about a real-world application. For example, imagine Trader Joe's is deciding whether to open a new store in central Illinois. They need to understand whether customers from nearby cities like Peoria, Springfield, or Decatur would be willing to travel to Urbana-Champaign, or whether it makes more sense to open a store in Springfield instead. Hierarchical clustering is capable of answering this question. In addition to that, it's deterministic. It doesn't require an iterative refinement process to converge. There are two ways to approach hierarchical clustering. We can start with each object as its own individual cluster and iteratively merge the closest pairs of clusters. This is known as the agglomerative approach. Alternatively, we can start with one large, all-inclusive cluster and recursively split it into smaller clusters. This is the divisive approach. By following either approach, we can generate a full clustering hierarchy, often visualized as a dendrogram. A dendrogram gives us a nested, tree-based view of how clusters are formed or divided at different levels of similarity. Let's walk through the visualizations. On the left side, the algorithm progressively merges data points into clusters. Smaller groups form larger ones step by step. On the right side, a dendrogram is being constructed, which is essentially a tree diagram that records the sequence of these merges. Notice how at the beginning, the algorithm starts by merging 2 points, then moves to merge clusters, which means we are going to need a distance or a similarity measure that can compute the similarity or the distance between 2 clusters instead of 2 points. In summary, we discussed basic concepts in hierarchical clustering.